Welcome everyone to the NREL, NCCSC, and ESS seminar. So you should know all those acronyms are. So if you don't, then you're in the wrong room. You're on the wrong WebEx or whatever this thing is. It's really a pleasure to sort of be hosting Managing for Climate Change, our fall seminar, and especially to have Shannon McNeeley being our speaker today. She's part of the research science team at the North Central Climate Science Center, and really been fortunate that she brings her skills as a social scientist as well as a great understanding of ecology to the efforts in the Climate Science Center, really building a really great adaptation team and effort, and working with various research groups in the state and broadly within our region, and also leading efforts nationally with the National Adaptation Forum, and she's on a steering committee for that. She's also been involved with the National Climate Assessment, where we first brought her onto campus back, I think that was in 2010, but she's been with us here at the North Central Climate Science Center as a research scientist since 2012. And her background and training in the social ecological work really started in Alaska, where she got her PhD, working with Terry Chapin and Gary Kofinas. So really fortunate to have that experience, as well as being a research scientist or on the research staff at the National Center for Atmospheric Research down in Boulder. So she really comes with a really great set of skills, and she'll really we have an opportunity to hear her presentation on how she uses that for co-production of research efforts here in the central US.
All right, thank you, Dennis. Thanks everyone for coming in today. So are most people here ecology students, I gather? Are there any social scientists? I know Trevor's a social scientist. Oh, hi. Other ologists in the room? Okay, so as Dennis mentioned, I'm an interdisciplinary social ecological climate scientist. I have training and background in all of those disciplines. I'm primarily an ecological anthropologist. So I really bring a systems approach to a social, natural, social ecological systems approach to the work I do. I'm not really going to get into much of the sort of conceptual or theoretical aspects of this project. I'm really going to talk about the partnerships for setting up this drought preparedness project at the Wind River Reservation, the process of how we're doing co-production with the tribes there at the Wind River Reservation, and some of the products. We're about a year into the technical assessment for this project, but it started about a year before that. There was a whole bunch of stuff that went into setting up the partnerships and providing some decision support tools before we even started the technical assessment. So I'm going to talk about that as well. So if you came for ecology, I'm sorry, you're not really going to get it today. You're going to get something completely different. Let's see if we've got moving. There we go. It's moving now. I don't know about this thing. So how many people are familiar with the North Central Climate Science Center? Show of hands. Okay, so good amount. If you're not, we're right next door. We are, thank you. We are funded by the Department of Interior, and this was created under a secretarial order under President Obama and Secretary Salazar in 2009, I believe it was. So basically our mandate is to do science and provide decision support to all of the agencies and bureaus and stakeholders within the Department of Interior, broadly speaking. So that means U.S. Fish and Wildlife Service, National Park Service, Bureau of Land Management, to a small extent Bureau of Reclamation, because they kind of have their own climate stuff going on. Bureau of Indian Affairs, and also tribes. We're actually in USGS, so it's a USGS university partnership. This is our North Central region. We're one of 8 centers throughout the US, including one in Alaska and one in Hawaii for the Pacific Islands. So this is roughly our geographic region. And the shaded areas are all the public lands in this region. So we have and it also includes Forest Service lands, which of course is under the U.S. Department of Interior. So we work with them a little bit, but they're not within the Department I mean, U.S. Department of Agriculture, so we work with them, but they're not in the Department of Interior. So we have a lot of tribes in our region and reservations. There are, I believe it's 31 federally recognized tribes in our region and 1 state recognized tribe. So these are the boundaries of the Indian reservations in our region, which doesn't of course include all of the indigenous population or even all of the tribal lands, because tribes have lands outside of the reservation boundaries. But this gives you an idea of the tribes in this region, or the reservations I should say. And today I'm going to talk about Wind River Reservation, which is right here in western central Wyoming. And it is the home of the Eastern Shoshone and the Northern Arapaho tribes. There are about 10,000 Arapaho tribal members, both on and off the reservation, and about 4,000 Eastern Shoshone tribal members. And then the reservation population is bigger than that. It's about 20 or so thousand, because there's a lot of non-Indian people that live there who are, a lot of them are landowners and are agricultural producers. The tribes were actually warring tribes historically. The Eastern Shoshone was originally their reservation. The Northern Arapaho tribe was placed there later in the 1870s. So while they have figured out a lot of ways to cohabitate and intermingle and work together, there's also been a lot of sort of historical conflict that resides today even. So the western portion of the Wind, oops, what happened there? Oh, I got a little message. So the western portion of the reservation is in the Wind River Range, so it's very mountainous alpine ecosystem. And then as you go out here into the plains, it's more of a sagebrush steppe grasslands ecosystem. So a lot of producers in agriculture, the tribal producers are primarily in ranching and livestock, and then the non-Indian, non-tribal producers largely live in this part of the reservation, and they do more kind of food crop agriculture. So the reservation has experienced, like we have in this area, significant impacts due to drought, especially over the last decade or so, and climate change. And so it's impacting them in many, many ways, like it is us here. So one of those ways is in terms of reservoir storage and water availability and water management. This is the Washakie Reservoir right here, where a lot of the Indian communities and producers get their water. Agriculture, so this is a sign from Arapaho Ranch, where again, they largely produce livestock. Fisheries, they have a lot of award-winning fisheries in the region, a lot of very significant fish species and riparian ecosystems that they're very concerned about. And so we're working very closely with the tribal water managers at the Wind River Tribal Water Engineers Office to help them with this drought preparedness project. So these are some of the folks that are on the Water Resources Control Board, so they're the decision-making authority at the Wind River Reservation. This is Mitch Contenor, who's the tribal water engineer, and he's actually a co-PI on this project. This is Richard Valdez. He is an Eastern Shoshone tribal member and former Fish and Wildlife Service biologist, so he's been doing a lot of the conservation work there at the reservation. And interestingly, they just finally last week reintroduced bison to the reservation after 131 years of not having bison at the reservation. And this guy right here was largely responsible for that. Him and his son, they worked very closely with the National Wildlife Federation and other partners to reintroduce bison. So that's really exciting because, of course, if you know anything about Native Americans, bison are really, really important to them culturally, in terms of a food source, spiritually, etc. So that's pretty exciting. So this overarching drought preparedness project has three main components that I'm gonna talk about today. One is this drought risk technical assessment. The second is capacity building and monitoring for drought impacts. And then the third is drought planning. The kind of overarching goal of this project is to help them develop a reservation-wide drought management and drought mitigation plan. So a little more details about some of the components that are within those three kind of headings is One is this project is really, really driven by the social science. So as I mentioned, I'm a social scientist. I'm one of the leads on this project. My co-lead, Cody Knutson, is the lead social scientist and drought planner from the National Drought Mitigation Center. So the two of us lead this very large project with a lot of partners and a lot of other scientists, but the social scientist is really driving it. So starting out back, even before the technical assessment started, I had some funding through the North Central Climate Science Center to start doing interviews with water managers at the reservation about drought risks and responses. And that's really documenting local knowledge and observations, and this is informing how we do the rest of the science. And again, I'll get into more details about that in a bit. So this is all, the technical assessment is this interdisciplinary, like I said, it's a social vulnerability assessment. We're looking at climate history and climate projections, so not just doing climate change assessments of future projections, but we're really looking at historical trends of drought and climate change to put everything into context, and then looking at future projections and what they can expect with future climate change, and then also ecosystem impacts, and that spans different vegetation and wildlife species. So capacity building and training. We are working closely again with the Tribal Water Engineers Office to help them build their own internal capacity for drought, preparing for drought and climate change. And so one of the things we've been working on is the development of a quarterly climate and drought summary that's a decision support tool for them, and I'll show you a picture of that in a minute. We've been working on training the staff at the Tribal Water Engineers Office to build their knowledge about drought and climate science and how to use the science and the tools for the decision making. And then we have a whole bunch of youth and adult water and drought educational activities that's funded through one of our partners, which is the University of Wyoming EPSCoR. If you don't know what EPSCoR is, it's an NSF-funded project that helps build capacity for science education in states that don't have the necessary capacity. Again, we're working towards drought planning. The project target, so to speak, is a reservation-wide drought plan, and really developed closely in conjunction with the scientists doing the technical vulnerability assessment, where while we've been laying the groundwork for the drought planning, we're actually formally starting the drought planning process next week. So that's pretty exciting. And then we've also built in a project evaluation into this project, and we're working closely with the Western Water Assessment down at CU Boulder, who's a NOAA Regional Integrated Science and Assessment RESA organization. Bets McNeeley is working with us to do an evaluation. So really what the evaluation is doing is helping keeping us honest. I like to say it's making sure that we're doing science that's actually supporting the decision making. This is often a piece that is really crucial but is left out of a lot of projects. So we made sure to build that into the project from the beginning through leveraging the NOAA funds and the NOAA Center to partner with us. So I'm going to go through some of the project activities to date. Now, this is a really big project with a whole bunch of components to it and a whole bunch of pieces. So I'm actually not going to be able to cover everything today, but I'm just going to give you guys kind of a thumbnail of what we've been doing so far. So this project really started in the spring of 2014 when I started going up to the reservation to work with them to understand what their needs were and to develop a proposal with them that was going to be submitted to the Climate Science Center to fund this project. It was a competitive process, so we had to compete for the funds like anybody else, but I helped them develop that project. And then I started doing the field work, doing interviews with them over the course of the following year. And again, that was really to document those local impacts, understandings, observations of drought and climate change impacts and responses. And that really helped lay a lot of the groundwork for what came with the rest of the project, because the relationships were built, the trust was built. And when you start a project, going to stakeholders and demonstrating to them that you really want to understand their experience and their context, it provides an enormous amount of social capital for the project that really helps, again, kind of build that foundation for everything else. So that's what I really spent the first year doing. I don't know why I keep getting this message on here. And then, as I mentioned, we've been working with them to develop this Wind River Reservation Climate and Drought Summary. That says 7 to date. I think we actually just put out the 8th one, if I'm remembering correctly. And again, I'll show you that in a minute. But one of the things we did in one of the first meetings we had with them is we said, you know, we're going to work with you on this proposal. It's going to take time. We're not even going to be able to submit the proposal till the fall of 2014. If we get the funding, it's not going to come till the next spring or summer. What can we do for you in the meantime to help you build your capacity? Fortunately, we were also partnering with NIDIS, the National Integrated Drought Information System, and they provided some of that really critical early funding to help develop this drought and climate summary and do some of the workshops and trainings that we've done. So we've had 5 workshops as of July 2016, where we've really been, again, focusing on these 3 components: the technical assessment, the capacity building, and the drought planning. And NIDIS helped us do that before the Climate Science Center money came to do the technical assessment. So this was another really important piece of that co-production and building those relationships and building the project together, so that we didn't just go there and say, we're going to write, you know, we're going to write a proposal and then we're going to come back in a year and we're going to do some science and then you're going to make decisions with it. They've really been partners from the beginning. So this is what we mean by co-production. So we also, with the help of NIDIS, sent some of their water technicians to the National Drought Mitigation Center and the High Plains Regional Climate Center, who are other close partners on this project at University of Nebraska-Lincoln, so that they could get trained on their tools there. As I mentioned, Wyoming EPSCoR is one of our partners. Jennifer Wellman is the Wind River Reservation Wyoming EPSCoR coordinator at the reservation there. So she's also a co-PI on this project. So her participation has been also instrumental, not only because she's someone there that I can work closely with to help develop the proposal and help, you know, give me feedback about what's going on there, but she's also provided these resources to do community outreach and education programs. So she's been doing K through 12 water science programming, environmental science field expeditions. They've done some GIS and drone work looking at watersheds and spatial analysis. They had a conservation camp. And again, this isn't everything. This is just some of the things I've been doing. She's been working with the Tribal Fish and Game and the U.S. Fish and Wildlife Service on wildlife habitat and fisheries education. So that has really been an important component to, again, build that kind of local capacity and community input and buy-in. And then, like I said, we're starting the drought planning this fall, and that is, we're having our first official meeting for the drought planning next week. And I didn't even mention, we've also had numerous conference calls and webinars for this project. That's a lot of what goes into the co-production, is making sure that the scientific assessment teams are in communication with each other, and we're in communication with the tribes. So we have ongoing monthly calls with the different teams, and then we have occasional, what we call all hands webinars, where we get everyone together and talk about what's going on with the project, and people present results to each other, etc. So as I said, the technical assessment started with the interviews with water managers that I conducted. I've done 23 in-depth water interviews to date with them. We've done 2 rounds so far of evaluation surveys that Beth McNeeley has conducted. There's a whole bunch of different ecological and climate analyses going on. I'll talk about some of that, more the climate stuff than the ecological stuff, because the ecological stuff is a little bit behind the climate analysis. But looking at things like historical snowpack, stream flow, drought indicators, climate projections. There's a sagebrush study going on that's out of University of Wyoming. There's a land change study that's going on, and white bark pine study that's part of a greater yellow ecosystem study with our partners at Montana State University. And then Jonathan Friedman at USGS and I also wrote a proposal to the Bureau of Indian Affairs with the tribes again to do a cottonwoods tree ring study and traditional ecological knowledge study where we're going to use these different ways of knowing and understanding about cottonwoods and the relation to historical water availability. So that's going to actually start in the spring. We've got a couple papers in progress already. One, we're calling Anatomy of an Irrigation Season. I'll talk about that towards the end. And then this originally was a book chapter that I wrote on water and climate adaptation using the Wind River case study. It actually ended up, I forgot to change that, turning into a special issue instead that we submitted to Weather, Climate, and Society. So this is the vulnerability assessment leadership team. So like I mentioned, you have myself and Cody Knudsen, who are the two leads. And as I mentioned, we're both social scientists. We've got our tribal partners here, Gary Collins from the Northern Arapaho tribe. He's the former tribal water engineer and a former tribal chairman as well. Mitch Contenor, who's the current tribal water engineer, who's a co-PI on the project. Al Seabearing, who's a water technician at the Tribal Water Engineer's Office, and both Mitch and Al actually received funding to work on this project. So that's one of the ways we built in co-production into the model, is we made sure that the tribes themselves have funding to work on this project with us. And then down here you've got our assessment team leaders. So Mark Svoboda at the National Drought Mitigation Center, who actually just became the new director of the National Drought Mitigation Center, and Imtiaz Rangwala at CU Boulder. There are two leads for the climate science team. And then Jennifer Wellman, as I mentioned, who's there at Wind River. She's a hydrologist by training, and she's the lead of our ecosystems impacts assessment team. And then this is actually our broader collaboration. So I don't expect you to be able to read this, but it's just to give you a sense of how we've structured this project, and we're really leveraging a lot of people and partnerships to make this a really strong project. And these are all the acronyms of all the different organizations that are involved. But just, you know, the way that this is structured is the Wind River Reservation decision makers and departments are at the center. They're the foundation of everything we do. The core project team that I just mentioned, that's made up of tribal members and scientists. Then we've got a local technical advisory group who's made up of agency and university folks that are there at the reservation. And then we've got this really broad, amazing group of technical support and project collaborations of scientists throughout the region. So this is a picture of the climate and drought summary that I mentioned. This is actually the first one that we produced in March of 2015. So again, this was done in very close collaboration with the tribes and the Tribal Water Engineer's Office and the Water Board, based on input we got from them from these workshops we had. Like I said, we're now, I think, in our 8th or 9th version. These are quarterly. The intention is that these are going to eventually be produced by the tribes themselves, which is why we built this technical capacity building component into the project. It's gone through different iterations. It looks different now. It looks kind of the same, but it's got different aspects to it because, again, it's this iterative process of putting it out there, talking to them about what works, what doesn't work, getting the feedback, tweaking it accordingly, making it more readable, making it more understandable, etc. So this has been a really important tool for us, not only for providing them with decision support tools and building all of that capacity, but also for getting our own ducks in a row, for understanding what data is available there, where the data gaps are, where we need to do science and try and provide additional data. So this has really helped us you know, catalog, so to speak, what data is available and where it is and how to use it and all that stuff. So how are we doing the scientific assessment? So this is how we've structured our science teams. This is actually a picture of our sort of scientific philosophy that we have for the North Central Climate Science Center, which is that at the middle are the management decisions and the managers themselves. Everything revolves around them, as I mentioned earlier. And then we've got these different disciplinary teams. The leads are in black here, and then these are the other scientists on the team. And everything we do, again, is driven by the center, which are the managers themselves and the management decisions there. And then all of this is in an iterative process with each other. These teams talking to each other, us talking to the managers to figure out how to do this really holistic project that has all these different components to it. So I'm going to talk a little bit about how the social science is informing the rest of the project. Again, I'm not going to get into everything. I'm just going to give you a little bit of a teaser. So one of the things that I've been doing is coming up with storylines. So as I'm talking to all these managers, what are the storylines that are coming out of that in terms of what's important to them that help us understand how we need to do our science? So one of multiple is the storyline that drought affects many things at the reservation. And those are key management issues and livelihoods. And so some of those things that came up as the most important issues for the managers there are reduced forage production. So that's, food crops for livestock and wildlife, actually, not just livestock. Impacts to livestock and herd liquidation in times of severe drought. Increased wildfire in forests and rangelands. Increased spread of non-native species like cheatgrass. Shifting plant communities, the sagebrush, like I mentioned, being an important one. They've got a sage grouse population there that has gone through different cycles, but overall it's declined like it has elsewhere, so that's a big conservation issue for them. Reduced productivity in upland range condition, and this is winter range for ungulates like elk and deer and antelope and moose. I mentioned the sage grouse, so how drought and climate change impacts lek size and sage grouse, fisheries die-off, and overall sort of water availability for the 15 beneficial uses in the Wind River Tribal Water Code. So another storyline has to do with the future, and this has to do with the fact that they don't have enough storage at the reservation where the tribes live and produce their agriculture. And so without getting into the details of their water rights that they settled, their tribal water rights, in general, half of their tribal water rights they can use now. They call that wet rights. Half of the rights in their adjudication are actually what they call future rights. So they're rights that they have to use that water in the future if and when they develop the infrastructure and the production in a different part of the reservation where they are now to use that water. And so there's a lot of questions that come up around that in terms of where water is going to be available, where they're going to be able to develop that infrastructure, and some other specifics that, again, I won't get into the details. This is a slide I presented to them in our workshop in July. But all of these issues that you have to consider in terms of where and how and when are they going to be able to use this water, especially in the context of future climate change and drought. So now I'm going to talk a little bit about some of the climate analysis that has been done so far. So this is Imtiaz's team down at CU Boulder. And one of the things that the interviews did was pointed us to the importance of looking at snowpack. They live in a similar environment that we do here, where they're really dependent on snowpack as a major source of their reservoir for their water. You know, we store water in reservoirs, but really the other reservoir we have is the snowpack itself, and as it melts throughout the season. And so snowpack is really important for them in terms of how those changes have been affected during times of drought and climate change. And looking at one of the big sources of data that they use is the snow tell sites. They also just their own local knowledge of, you know, how is the snow doing this winter compared to last winter? What does it actually look like up there? When they go up there, what does it look like? What's the quality of the snow? Things like that. So one of the things the climate team has been doing is looking at snow tell sites in and around the reservation to understand what kinds of trends we're seeing in those snow tell sites over the last, you know, however many years. One of the big issues for them, and again, this is an issue for us here in this basin, is changes in the timing of snowpack, or I should say the timing of precipitation, and whether that comes as snowpack or rain. And again, if you're getting a change of snow coming later in the spring in the form of rain as opposed to snow, that water and snow melts off the mountain and it goes through the system before they can actually use it for irrigation for producing crops. And so it's really important to have that snowpack reservoir in the mountain and that slow snow melt off that comes throughout the season. When you get those changes of earlier snowpack runoff and precipitation coming up as rain as opposed to snow, then you have problems in terms of water availability. And so one of the things the climate team wanted to understand is, are we seeing a trend? What does it look like in terms of this dynamic of rain versus snow? So this is the analysis that they're doing, they came up with a calculation to be able to look at the SNOTEL data to understand that dynamic, because the SNOTEL data doesn't actually tell you what form the precipitation comes in. So they had to calculate how much of that is coming as rain versus snow. So you're not seeing there we go. So this is one of the outputs the early outputs they did. Again, this isn't final data. This is just some initial results. But looking again at this dynamic of total precipitation, and then snow water equivalent, and then these are the actual, and then these are the estimated. So basically what you can tell here is how much is coming as rain and how much is coming as snow. Another thing that the interviews do is, one of the things I asked them about is to tell me about their observations of drought impacts in the most impactful droughts that have happened in that region. And so what I do then is I code the interviews and I come up with a list of what those years are and how they talked about it and what kinds of impacts happen. And then we can go into the data and look at these different years and kind of map out, you know, what the trends were and how climatologically what was happening there in these years that they talk about these drought impacts. What that does is it gives us an understanding of this dynamic between impacts and what's going on in the physical climate and hydrology system. And so we can really start to unpack these relationships and get a sense of what's important to know when you want to create a drought preparedness plan and an early warning system to understand if and when and how drought is going to impact the reservation. So another thing that we're doing is, or the climate team is doing, I should say, is also looking at future projections. So this is the output of multiple models that Imtiaz and his team looked at. And kind of the overarching story is that, you know, there's going to be, of course, warming. We all know that. And then overall, the models show a slight decrease, but most models actually show increases. But the important aspect to know about that is that while climate models for this region project an overall increase in precipitation, what's really important to understand are these dynamics that are happening that actually still cause drought and water shortages. Even though you might have these sort of average annual precipitation increases on the ground in certain areas where you've got these dynamics that are happening between all of these issues like evaporative demand, and the changes in the timing of rain versus snow, like I said, you're still going to have drought, you're still going to have water shortages. So again, these are the important kind of nuances and dynamics that we're trying to understand from the local observations, historical trends, and then what do the models tell us about what you're likely to see in the future and what are the implications of that. So this is kind of a summary that Imtiaz gave of some of those changes that are likely to come. Again, timing of snow-related processes, soil moisture stress, growing and fire season length, and extreme precipitation events. And in fact, we're already seeing a lot of this. Climate change is here. We know that these changes are already happening. Scientists are trying to still parse out, you know, how much is climate change versus natural variability. Those are really tough scientific questions to crack in some cases. But we're already seeing a lot of this, and we're going to see more of it. So the other, as I mentioned, our climate team has two leads, Mark Svoboda at the National Drought Mitigation Center. So what they're bringing to the table is using a lot of their tools they have there at the National Drought Mitigation Center to look at these historical trends. So if you're not aware of this link, this is the Drought Risk Atlas. This is a relatively new tool. It's droughtatlas.unl.edu. It's a very, very useful tool for looking at all different drought indicators throughout the country. So we're really fortunate to have these guys on board as part of our technical assessment team, because they're bringing in these tools as they're developing them, and they're actually, some of the stuff that we're doing in this project is influencing what they're doing in terms of developing those tools. So again, it's really this iterative process. So this is just showing one of the outputs that they provided, which is a 6-month standard precipitation index in the counties that are in and around Wind River Reservation. And then again, this interaction between the co-production model that we've set up, this interaction between the water managers through the workshops and the conference calls and the webinars and my interviews, is that we're really trying to understand, you know, there's a whole bunch of different ways you can slice data, as you guys all know, and how you look at it matters. And so we're really trying to work with them to understand what are the time scales and spatial scales of the decisions that they're making, and how does that influence the scales at which we look at this data. And then again, putting into the context of historical droughts, so this is just showing trends from 2000 to 2016 in those counties in and around the reservation. And again, we can look at it, and from the interviews where people talked about these big drought events, we can then look at the data and say, yeah, this is what was showing up in the data in terms of drought severity in that region. And then another exciting piece of the project that we're bringing into it through NOAA and Mike Hobbins and MTS and others at NOAA is the Evaporative Drought Demand Index. This is a relatively new tool that, for lack of better words, looks at atmospheric thirst. I can't go into detail about everything that goes into this, but you can see a summary right here. Basically, this is one of the outputs that they did looking at drought. I think this was from the year 2015, two different kind of time slices that summer of what was happening on the ground using this Evaporative Drought Demand Index. And it turned out that the EDI, we call it, showed drought in the system before the US Drought Monitor did. And so that was a really important thing. And this was something that we kind of ground to truthed at one of the workshops with the managers there, because we showed them some of the output from the EDI. And then we said, you know, how does this map on with your experience? And it turned out it reflected really well what they were observing that summer. They had a water shortage the year of 2015. I'm going to talk about that more in a minute. So this is a really exciting thing because, again, this project is really a test bed for a lot of these tools that we're working with NOAA and the National Drought Mitigation Center, and feeding back to help them inform the further development and use of these tools. So that's pretty exciting. So I mentioned this 2015 year. So this is one of the things that we're looking at, and we're writing this paper on across these disciplinary teams. I'm leading the paper with my colleague Candida down at NOAA, and what we're calling it is a microdrought, and we're unpacking what happened during the irrigation season of 2015 to cause a water shortage in part of the reservation. And so we're just looking at this timeline of what was going on with the snowpack. They had low snowpack in the winter. And then in May, they just had this deluge. Interestingly, this almost exact same thing happened again this year in 2016. And what this did was it caused the snow water equivalent indicator to go way up because of that heavy rainfall. But what happened was, as I mentioned earlier, they didn't have that snowpack up in the mountains. And so as the season went on, they started to run out of water in the Little Wind River system because Washakie Reservoir didn't have enough water to sustain them through the season. And so this is one of the dynamics that's happening there, and it's happening with more regularity. I mean, the basic fact of the matter is they don't have enough storage in this system. And so this is one of these issues that ecologists really need to understand, is that, you know, we've got some very serious trade-offs to think about when it comes to having water in a climate change future, while also having water for ecosystems and fisheries and riparian ecosystems. And this is actually something that's very important to the tribes, in that they're working very hard to try and manage. And so there's a whole bunch of things that they've done to improve their infrastructure and their guidelines for how much water to remain in the system for the fish and for riparian ecosystem health. But the other problem that they run into is that the producers, the livestock and the agricultural producers on the reservation don't fully understand that these dynamics are going on. So all they know is they ran out of water and they don't have enough water to get them through the season. So they get that backlash from their local producers. So this is one of the things that this project is helping them do, is arm them with the data and the technical capacity to really be able to work with their stakeholders and their producers to educate them about what's going on and manage the system for these multiple uses. And so, let's see, okay, cool. So I'm just gonna end with something that I talk about in a lot of these talks I give, which is lessons learned for working in Indian country. So I do a lot of work with tribes. I've been doing work with tribes for many, many years. Like Dennis mentioned, I got my PhD in Alaska, working with tribes up there, looking at similar issues, climate change and fish and wildlife management and so on. So I have a lot of experience working with tribes, and I like to talk about some of those lessons that I've learned. The first and foremost, most important thing is when you're working with tribes, and by the way, this actually applies to working with a lot of different stakeholders, but some of the things I'm going to talk to are particularly important with tribes. But, you know, I've worked with super conservative climate change deniers in Northwest Colorado to really, you know, liberal environmentalists and tribes. And so all along the spectrum, all these things are important. But when you're working with tribes, you know, there's a real long-term historical legacy. I'm sure you guys all know about the conflicts between tribes and the Euro-white American culture and government. And so no matter what your intentions are, no matter how much money you come with, no matter how smart you are, if you don't have those relationships and that trust built, you're not going to get anywhere. So this is why, like I mentioned, I spent a lot of time in the beginning really focusing on building that trust, going back to the reservation again and again, and just sitting and listening and talking to them and understanding their context and understanding their needs. If you don't do that when you work with tribes, you're going to get nowhere fast. Part of that is just listening and learning. As scientists, we are taught that we lead with our brains. We lead with how we articulate things. We lead with how smart we are. In Indian country, you have to lead with your heart. And if you can't make that heart connection, they don't care what you know. They don't care how smart you are. They don't care about any of that. You've got to sit and you've got to listen and you've got to learn. And that's a really important skill that a lot of people don't have, and you have to really develop if you want to work in Indian country. As part of that, you have to respect the culture and the local knowledge, and to the best of your ability, incorporate that local knowledge and traditional ecological knowledge. You know, a lot of Native Americans are still very, very, very connected to their landscapes and their natural environments. And again, this applies beyond tribes. I mean, water managers, agricultural producers, a lot of people that, you know, work out in these landscapes and are very connected because they have to be. They're very connected to their environment, the natural systems, the climate system. To the best of your ability that you can incorporate that knowledge, again, that's really going to help your science and your understanding of the applicability of your science in those contexts. Find a way for early deliverables. As I mentioned, you know, something that was really important for this project was working with them to develop that Wind River Climate and Drought Summary in the beginning. And that was something that really helped provide a mechanism, again, for, you know, building all of the capacity and the relationships and the knowledge throughout the team and the tribes for the rest of the project. So, I'm sorry guys, this little message keeps coming up. End-to-end co-production. So as I mentioned, you know, a lot of people think of co-production, and there's different ways to think about co-production. There's no one perfect way. There's a spectrum. In Indian country, I personally think, and I'm not alone in this, that using this model of deep co-production is really essential. Because again, you've got all these issues of trust and relationships and so on. So co-production, when I talk about co-production in this sense, again, this starts from day one. This isn't, we have a meeting, we listen, we go back, we write a proposal, and then we come back and do our science, like I mentioned earlier. It's actually working very closely with them to develop the proposal from the beginning, make sure that they are in the proposal, and you're including funding for them in the proposal. I can't tell you how many times people come to me and they say, we've got this great project, you know, the tribes are on board, we want to engage the tribes. And I say, well, do you have funding for the tribes? Well, no. It's like, well, they need to get paid just like we do. And so a lot of people forget this part, and it's a really important part. Make sure the funding is in there for your stakeholders to the best of your ability. Work out a protocol for managing and sharing data and information. This is crucially important with working with tribes. There's a long history of people coming into Indian country and wanting to use their TEK, their local knowledge, their traditional ecological knowledge for their own project, and then they go away and they publish papers and they do wonderful things, but they never get back to the tribes. And sometimes there's sensitive information in that knowledge. There's sacred information that they don't want shared. And so making sure from the beginning that you work out this protocol of how are we gonna share information? Who's the decision-making body about what we can share and when? What's the process for that? So one of the things that I've done in my work with tribes is one of the first things I ask them is, do you have your own tribal research protocol? Sometimes they do, sometimes they don't. In the cases when they haven't, I've actually worked with them to help them build their own research protocol. I've used other tribal research protocols and give them a template, and they kind of make it their own, and then that becomes our guidelines for how we deal with this issue, which is data sharing and management. Find ways for regular communication, but respect people's time. So again, the way we've done this in this project is having these really regular calls and webinars. We basically said to the tribal water engineers, because they're busy, this is not their highest priority. It's important to them, but it's not their highest priority. They're governing water for a nation. And, we said to them, we want you to be part of this, but we also want to respect your time. So participate as you want. We'll invite you as much as you want. And they said, that's cool. If we can make it, we will. If we can't, we won't. It turns out someone from the tribe comes to pretty much every single call we have. Let go of expectations. You're working in a different nation when you go into Indian country. And so, it's good to have goals and objectives and ideas about how you'd like things to go. But usually it's not going to go that way at all. And so you just have to be really, really flexible and really, really adaptable and kind of be open to whatever happens, because it's not your culture, it's not your way, and your job is not to impose your way. Your job is to work with them in their way. And then lastly, find ways to give back to the community. One of the best ways to do this is work with students. So every project I do, I find ways to engage students into the project, and also the elders. Elders play an enormously important role in Native American communities. And so anytime, they're still the ultimate leadership. They have their governing bodies, whether it's their tribal council or business council or whatever. But at the end of the day, it's the elders that they really look to. For guidance and for leadership. And so any way you can include the elders is going to benefit your project. So that's all I have to say. That's it. So thank you very much.
Thanks, Shannon, for sharing all that. I'm sure there's questions. Open floor.
Yes.
Yeah, I was curious about this challenge of water storage under climate change, and sort of maintaining both sort of the social value of the water react and so forth, and ecological values. You mentioned that they didn't have enough storage, so you use, late season, what would be snowfalls, I guess, and they now and rain has to flush through the system. And you mentioned that there were constraints on how much water they can use for their reserve water rights or whatever. So who owns that water that's coming early and going through the system that would otherwise be in the snowpack, and sort of keep that reservoir topped out over a much longer period of time?
So that's a great question. The tribes feel that they own the water. The problem, of course, is that they feel like their water goes downstream, and then people off reservation end up getting to use what is rightfully theirs. And the storage issue is actually only in certain parts of the reservation. The whole makeup of management and water storage and ownership and allocation is extremely complicated there. You've got actually largely 4 different systems on the reservation. I'll show you the map, in fact. This is gonna take a while to get back there. Let's see. So the part where the tribes primarily live and work is the storage is actually, the infrastructure is actually, where's the map? Is actually owned and operated by the Bureau of Indian Affairs. And so, oh, I lost the whole thing. I don't know how to get it back. All right, well, never mind. I was gonna just show you throughout the map, because the Little Wind River system is where most of the tribal communities and producers are. And that is, oh, cool. So this is this part of the reservation right here. And the BIA, like I said, owns the infrastructure, the reservoir and the irrigation system. And so the tribes have to work with the BIA to negotiate those releases. And this is where a lot of the problem comes into play. There's a whole other story I didn't tell in this presentation that I've told in other versions of this talk, where in the year 2013, the BIA didn't manage for drought. It was, you know, if you remember, the 2012 drought lingered into 2013 until we got that rain at the end of the season. The BIA didn't manage for drought. They let all the water go. And the tribes, they had to cut off the irrigation season like in July. They only had like a 30-day irrigation season. That water is technically theirs, but they don't have the storage, and so it goes down the system. So where it ends up going is out here in Riverton, where there's a lot of, there's some Indian, but a lot of non-Indian producers. And then into this big Bureau of Reclamation, it's called Boyson Reservoir. So this whole, on the big one, this whole system right here is actually Bureau of Reclamation. And that's where a lot of the non-Indian producers are. And then you've got another part of the BIA irrigation project up here in the Crowheart area. And then there's a whole other one up that's mostly state managed on the northern part of the reservation where Arapaho Ranch is, where Anchor Dam comes out of. And there's been, the figures I've heard is there's been about 10 times investment in the Bureau of Reclamation system. So they've got this like super high tech computerized system of head gates and, you know, canal operations and all this stuff. And I should have shown pictures, but the BIA system, it looks like a third world country. It really does. I mean, it's really not a good situation for the tribes. And so that water goes into Boyson Reservoir and goes downstream. So this is one of the conflicts that the tribes have with the Bureau of Indian Affairs, the state of Wyoming, who actually has, like in all states pretty much, they have primary authority of water management, and then the Bureau of Indian Affairs, Bureau of Rec. I can't remember which one.
To build more, to request more infrastructure, hearing that it have to be approved and managed by the BIA, which I guess I'm not an expert in this area, but I've certainly heard a lot of things about the BIA.
They struggle. So actually one of the things that's going on right now is they have commissioned through this, the tribes have commissioned through the state storage feasibility study. And so they've contracted some folks, some of which are actually here in Fort Collins, to look at where they could store additional water throughout the reservation. The likely thing that's coming up is that they're gonna have to build bigger storage in the storage systems they already have. So Washakie Reservoir and another piece that's connected to that called Ray Lake. But like I said, there's this whole futures water issue, and where they think they can use the futures water is actually up here on the big one, but there's no tribal producers up there and there's no infrastructure. So these are all the questions about how is that gonna happen? Where's water gonna be available, et cetera, et cetera. So it gets pretty complicated. Yeah.
Shannon, this is such a cool project because there's so many different layers, and I appreciate you walking us through them. I guess I'm just curious, you know, on these big interdisciplinary projects, usually you see natural scientists as the leads with
Right. Scientists
mixed in somewhere along the line. And I'm just curious, how has it worked with having 2 social scientists really as the lead, working with a bunch of natural science? What's worked well? What have been the challenges?
Well, I'm biased, obviously. I think, you know, one of the biggest challenges and we face this, I think, with the North Central Climate Science Center as a whole, is not being co-located. You know, as much as we build in that ongoing regular communication, we really could use more. And that's been a challenge. So what ends up happening is, as much as you try and integrate and as much as you do integrate, you still got sort of this, a little bit of a balkanization of where things are happening. You know, so you've got these folks doing this over here, and these folks doing this over here, and these folks doing this over here. And so you can never quite be as integrated and interdisciplinary as you want to be unless you're all together and you have a mechanism to really be working together all the time. So I would say that's one of our biggest challenges, is just geography. Aside from that, I mean, I don't know, you'd have to ask the other scientists in the project to see what their perspective is on how it's working. But I personally think it's working great, because when we put together this project, you know, part of the reason that this project happened in the way it did is because of the connections that already existed between these people and organizations. I've been working in this field for a long time in this region, so I know a lot of people, and so do all the people I'm working with. So we really handpicked the best of the best for this project. And when I say the best of the best, what I mean by that is not only people who do top-notch science, but they're good, open-minded, flexible people who actually respect this type of work and are willing to put in the extra time it takes to do this work, so it becomes a labor of love. You know, I guarantee you everyone on this project is not getting paid for all the work that they're doing. So, you know, you've really got to find those people out there who are on board with this type of project. And I would say by and large, we've been really successful at that. So we're lucky that we have this broad team of people that really value both the interdisciplinarity and the cross-cultural aspects of the project. So they really look to the tribes and to me to help guide them in terms of how to go about doing this project, because you can step on a landmine like that and everything can blow up really easily. So you got to be really careful and thoughtful and strategic about how you do this kind of a project. So, so that is a challenge, because it takes a lot more time and it takes a lot more effort. I mean, a lot of my time personally is spent managing this project, herding the cats, you know, making sure everything's moving and you know, the wheels are greased and everything's turning and moving forward. I have other people that help me do that. I'm not alone doing that, luckily. But it's a big endeavor, and this is part of the problem with, part of the challenge, I'll say, with co-production, is it takes a lot of time and a lot of effort and a lot of resources and a lot of patience. So things move more slowly. I would say that's another challenge, is that both because of the interdisciplinarity and because of the co-production model, we can't move as quickly as we would otherwise like to. So that's definitely a big challenge with this project. Yeah.
So to follow up on one other question, and you got at some of the things that I was thinking about in that last answer, a lot of scientists are reluctant to even approach a project that works with tribal communities, Americans in this country, because of the extra time investment that you just talked about, the need for that co-production and cultural respect, the potential to step on one of those landmines. What is your sales pitch to bring so many people together and so much funding on a really cool project like this, when there are all those kinds of like systemic racism kinds of barriers that we deal with, right? And
yeah, and that's a great question. Like I said, I mean, for me personally, it had to do with the fact that I did already have a lot of those connections, and a lot of people on this project are actually my very good friends, you know, and so again, I kind of knew who to approach and how to approach them, and I knew that they were going to want to be part of this project. You know, a lot of the, with that said, a lot of the emphasis under the Obama administration over the last 8 years has been a focus on working with indigenous communities. So all of the federal agencies have had not necessarily mandates, but strong encouragement to work with tribes and support Native American communities. And a lot of them don't know how to do it. And so a lot of these people, you know, are actually kind of excited about the possibility of working with tribes. And so again, it was just kind of, I mean, it took a long time, believe me, I can't tell you how many phone calls and visits and, you know, getting people to buy into this project. But to be honest, it wasn't that hard of a sell, because we had a unique opportunity. That was probably my biggest pitch. It was like, look, these guys are on board. We've got really strong connections. We've got, you know, we're working on a proposal. We've got NITIS involved. We've got these people. So it was just, you know, it was not a hard sell at all, to be honest.
Thanks again. Well, I think we need to wrap up. I'm sorry.
You can ask me after.
And yeah, I think Shannon will be available for additional questions. So thanks again, Shannon.
Thank you. Thanks, everyone.
Next week, we have the opportunity of bringing in Keith Postian, one of the NREL scientists, to talk about his work. And that'll be the sort of our last speaker before the fall break. So welcome back next week. Thanks. It was great.
Yeah.
I'm not sure exactly what we all do.
Is it Sharon?
Shannon.
Shannon. Okay.